Hello, I'm Thulitha Bandara. I'm going to explain you about three most popular sorting algorithms: bubble sort, selection sort, and insertion sort. When comparing these three types of sorting algorithms, we can clearly note that bubble sort and selection sort do the swap method, and insertion sort do the shift method. Firstly, let me talk about what is bubble sort. Bubble sort is the simplest as well as the slowest iterative algorithm operates by comparing each element with the next element to it. We do swap for those two elements if we need to do so to set them in order. You can get a clear idea about bubble sort by viewing this simple example. Let's sort an array in ascending order. Assume an array consisting of the values 2, 3, 8, 5, 7, 6 respectively. At the index 0, the value is 2, and at the index 1, the value is 3. So we are going to compare these two elements. These two values are in ascending order because value 2 is always less than 3. Therefore, we do not have to do a swap in here. Then, we are going to compare the value 3, which is at index 1, with the value 8, which is at index 2. In here also, we do not have to do a swap. Then, we jump to next step. Compare value 8 with 5. We know 5 is less than 8. So, we need to do a swap in here. The value 5 will be placed in index 2 and 8 will be placed in index 3. And next, we compare 8 with 7. In here also, we should do a swap because 8 is greater than 7. Then compare 8 with 6. There also we have to do a swap. Now you know the largest element is 8. So we place that value in last index of array. And we never check that value again because that is unnecessary. Then we have to start from the beginning. We have to compare the value 2 with 3, 3 with 5, 5 with 7 and 7 with 6. In 7 with 6, we have to swap the values because 7 is greater than 6. So we should swap these values. So this process will happen until all the elements be placed in right position in ascending order. In here, you can see that values are in order. So I am going to visualize the final result. But in the code, it will loop until the situation where only the remaining 0 and first value being checked. The code for bubble sort for ascending order is this. First, we want a temporary variable in here and a loop inside a loop. In the inner loop, we need to place a if condition to check whether number before is greater than number after or less than number after. In here, j represent number before and k represent number after. In the if condition, if the number before is greater, we put number before to 10 and put value number after to number before. And number after get the number value of 10. Then it will loop until the array is being sorted in ascending order. Now let me talk about selection sort. In the selection sort, we divide the array into two partitions as sorted partition and unsorted partition. When doing the iteration, we select the minimum element from unsorted partition and move that to sorted partition. Let's take an example which do a sort in ascending order. Assume an array with the values 3, 6, 8, 5, 7, 2 respectively. At the beginning, we always set current first element of unsorted partition as the current minimum value. Then we set the minimum value of unsorted partition and then we swap those two values. That means the selected minimum value moves to the last index of sorted partition and the element which was at first index of unsorted partition before swap is going to the place where the selected minimum value was. In here, the sorted partition is illustrated in yellow in color and unsorted partition is illustrated in white color. First, we take 3 as the current minimum values because that's the first element of the array. Then search for minimum value. We get 2 as the minimum value. So we should swap these two values. Then take 6 as the current minimum value and search. We get 3 as the minimum value. So we should swap them. Now you can clearly see the sorted partition appears in yellow in color. Then set 8 as the current minimum value and search. We get 5 as the minimum value. So we should swap 8 and 5. Again, we have to take 8 as the current minimum value and search for the minimum value. We get 6 in this time. So we should swap these two values also. Then finally we get 7 and 8. So we take 7 as the current minimum value and search. 7 is less than 8. Therefore, these values remains as this way. And we can confirm that array is being sorted in ascending order because in the diagram all the elements are now in yellow in color. Now let me see the code for selection sort. This is also a little bit similar to bubble sort. We use a loop inside a loop in here also. And in the inner loop, we have to use the if condition to compare values. We get a temporary variable here. And we are going to place the minimum value in relevant position in array by these few steps. That's the way of doing selection sort. And the last sorting method we are going to discuss is insertion sort. Basically, this is different from previous methods because this method does shift rather than doing swap. And this is a straightforward sorting algorithm. It constructs the sorted array by inserting single element at a time. Let's do an example and get further idea about insertion sort. In the example, we do a sort in ascending order. In here, we examine each item and compare with elements in its left. And then we insert that element in the correct position of the array. Assume the array has the values 2, 3, 8, 5, 7, 6 respectively. So we have to start from 2, but there is no element in left. So value 2 will be placed in the same place as it is. Then take 3 and check left. 2, then 3. So these two values are also placed in this order because these are in ascending order. Next, we have to take 8. We want to check the left side of 8. 2, 3 and then 8. So here also no change. Then take 5. When checking with the left side of 5, the value 8 is present. So you know 8 is greater than 5. So we need to shift 5 in between 3 and 8 because 5 is greater than 3 and less than 8. And now we want to get 7 and check left. So in here also you will notice that 8 is greater than 7 but 7 is greater than 5. So shift 7 to the position between 5 and 8. Then finally we have 6. When looking at the left of the value 6, 6 should be placed in between 5 and 7. So 6 should be shifted to that place. So you will notice that the array is being sorted in ascending order. Now let me see the code of sorting method. First, we have to create a for loop. And then we want to set a variable to save the element at index I. Then we want to access elements starting from the previous index which is I minus 1. Then we are going to check the current element is less than these elements. So simply this is the code for insertion sort. By analyzing these things, we can conclude about the three sorting algorithms. The key differences between three algorithms are functional type, stability, speed, efficiency and method. The functional type of both bubble sort and selection sort is swap. The functional type in insertion sort is shift. When considering the stability, we can confirm that both bubble sort and insertion sort are stable, while selection sort is unstable. And the speed. Bubble sort method is the slowest among all the sorting algorithms, and selection sort is faster compared to bubble sort, and insertion sort is faster than both of these two algorithms. And bubble sort is really inefficient, and compared to that, selection sort is efficient. But the insertion sort is more efficient than these two algorithms. And the method of bubble sort is exchanging. Method of selection sort is selection. Method of insertion sort is insertion. These are the key differences between bubble sort, selection sort and insertion sort. Thank you.